Hello, my name is Matt Kern with Balance Eco Solutions, and today I'm going to be talking about advancing beyond the draft biological evaluation of Carbaryl for federally listed species. I'd like to acknowledge the sponsors and co-authors of this work from NovaSource TKI, Gestif and Pixis, and Applied Analysis Solutions. The point of this work is to demonstrate how product and species information can be applied to bridge the gap between biological evaluations and biological opinions for federally listed species. So the goal of this is to incorporate the best available information into relevant lines of evidence that can be used directly to determine the likelihood of risk to a listed species for relevant uses. The larger litmus test for all this is to answer the question, can we directly connect risk management practices or decisions for a particular stressor with reductions in species-specific impacts? And that's a tall order, but I think if we aspire to be more specific in our risk assessments and accurate, we're more likely to have risk management decisions and practices employed that actually do have a direct and linkable impact. In terms of the big picture, we hope that our work fits somewhere between the national scale view of a biological evaluation that really is designed to ask the question, is there potential for any exposure to occur for listed species, to support species for those listed species, for any use pattern? And over on the right, the biological opinion that is intended to be highly species-centric and ask the question of likelihood of exposure. So somewhere in the middle, we recognize there's a need to bridge those two by providing regional product-specific expertise, context around the BE exposures used in those biological evaluations, but also some of that local information to look at other distributions of exposures that are maybe more relevant for a species. Species information, largely that information that's publicly available from the services, and how that may apply to our use and usage information in terms of relationship, and then overall spatial and temporal context around where these products are used, how they're used, and when the species may be and when, and that sort of thing. So these are lines of evidence with the hope of increasing the relevance and the reliability of these assessments, specifically into the biological opinion, such that with this added detail, as you move from left to right in all this, added detail, you get mitigation relevance increases if needed, species protection increases, and overall resource management of the species and also the assessment resources become better utilized as you focus on a more narrow invaluable, hopefully, assessment along the way around species-specific potential risk. So I want to demonstrate some examples here of lines of evidence that could be utilized as part of this effort, starting with the Wenatchee Mountains checker mallow. It's a plant species. It's highly endangered. It's located in one county in eastern Washington. In fact, its known locations are very specific and well surveyed and studied. It does occupy wetland areas, often in areas with saturated or soils or standing surface water between 1,600 and 3,300 feet. The major reason for decline for this species is habitat loss and climate change as it relates to temperature. The species is known to be very sensitive to temperature, and even at those altitudes where it's known to occur, temperature is rising, and there's real concern about the specific soil needs of the species and the elevation needs and the ability for those to line up in a way that the species can actually survive, let alone recover. So real concern there in that regard. Now we'll mention that the draft BE findings were that there's strong evidence for a likely to adversely affect in terms of Carbaryl in this species. That's again combining all uses together across the country. So a little bit more information on the checker mallow. Again, as I said, it's well studied and well surveyed. The largest population, which isn't a very large one, is on Camas Meadows. The majority of the population is managed by the Washington Department of Natural Resources. Another small population is in an area very spatially defined, surrounded by homes. So residential development is a real threat to the species in that location. Another small population of about 160 individuals is on a modified wildland setting. And then finally, two other small populations are on areas owned and managed by the state of Washington. So let's take a closer look at these areas. The area in purple is the overall range of the species. The area in red is the critical habitat of the species. You can see an area that's sort of an orange-yellow. That's those known locations of the species. Finally, those potential orchard use sites are in green. Now, this critical habitat is zoomed in a little bit to give you another perspective on where these known populations occur within the critical habitat. So there's a few ways we can look at this to get familiar with the likelihood of an intersect between these use sites and species of various habitat descriptions. So what you see here in red still is the upper edge of a critical habitat, and we looked at what's the closest or the shortest linear distance between use sites in green there and critical habitat, and we found in this case it's a little over 1,600 feet. So anyway, just gaining some perspective, not a formal analysis yet. Same thing true for closest distance between use sites and those known locations. So in this case, the closest distance that we have, linear distance, is a little over 7,000 feet. So gaining some perspective on those relationships. The other thing we looked at is the topographical relationship between potential use sites in these habitats. So not just the linear distance, but also topography, and in this case, elevation. So we're looking again at that one of the same spots around potential use sites and one of the closest known locations to the species. And you can see already from this aerial imagery, you're getting into a mountainous region, which again makes sense based on in yellow. That's a known location, by the way. It makes sense that you're seeing elevation changes based on what we know about the species and where it exists. But the point here is, in a linear fashion, the distance between this particular potential use site doesn't mean Carbaryl will be used on those orchards, but it could potentially be. And that known location is a little over 2,000 linear feet with an increased elevation use site to known location of over 800 feet. So when we start to think about drift distance, this starts to be really meaningful in terms of the likelihood or the potential exposure that might occur for the species. So I mentioned earlier about making associations between those habitat descriptors and potential use sites for Carbaryl. So again, we're looking at the species critical habitat specifically here. And we're applying the area in light purple is a representation, spatial representation of those wet areas or those moist soil areas where the species could exist. The areas in purple actually correlate those areas with elevation where the species can occur. And so you can get a much more refined view of where the species is likely to exist or could exist. And interestingly, this particular area lines up very well with known locations for the species. And maybe a couple of areas out here where wouldn't be a bad idea to take a closer look potentially on the species. So by and large, there's a pretty good distance between potential use sites and these real usable locations for the species. A couple of exceptions, a couple of pixels here and there, where in this case we're a good distance from use areas. In this case, we have one pixel showing up here where there could be potential use, and need to take a closer look at that to see if that's actually relevant given the elevation shown here. So this is a look at some of those state and federally owned and other managed lands in association with critical habitat for the species. Again, we're in critical habitat, known populations. You can see surrounding the known populations is a lot of state trust land. The dark green areas are Forest Service land, and you can see here some other state descriptions. So this, again, it's qualitative in nature in the sense that it gives us some perspective on other land use proximate to the species. Some quick summary statistics for those areas. Areas within range that are managed is almost 89% of that total range area. Managed lands within the critical habitats about 33%. Managed lands around known locations is about 80%. Suitable habitat within range is a little over 3% or close to 3%. And when you combine suitable habitat with elevation, it's about 1.1% of range. So giving some perspective there. So I want to very quickly share some of the analysis for these various habitats that I've already mentioned. That is range, critical habitat, known locations or populations, suitable habitat based on wetlands and soil type, and then suitable habitat with those soil types plus elevation combined. So in this particular case for this scenario, for direct effects, that is toxicity to plants, and indirect effects, that toxicity to pollinators. So we split those up based on their thresholds to get it different overlaps between the two. We basically find that we're looking out to zero distance, so we're on use site distance for direct effects and out to 48 feet for indirect effects. But in terms of direct overlap with range going out to 48 feet in zero, so we've got 1.6% overlap with range, 2% when we consider indirect effects. For critical habitat, no overlap. For known locations, no overlap. For the suitable habitats without elevation, you get an overlap of 1.2 to 1.6 in that range. And then with the elevation included, it's zero for direct effects and very slight overlap without checking those pixels for indirect effects. So this is a fairly robust and comprehensive way to look at that overlap using those thresholds that we're using the BE to get a sense of potential exposure. So next steps, we're looking at an evaluation of some other minor agriculture uses in this area, looking at modifications based on agronomic information, so things like percent crop treated in the area and application timing. Finally, we're putting all this into an integrated exposure assessment tool that looks at the frequency, magnitude, and duration of potential exposure, and putting all this into a compiled set of lines of evidence that can be picked up and easily used by the services or other stakeholders as part of the effort. With that, I thank you for taking the time to view this presentation, and I look forward to comments.